Welcome to Civil Engineering Edge. Today, we dive deep into concrete mix design using Indian Standard 10262 and Indian Standard 456 guidelines. Mastering concrete mix design, M20 grade, for maximum strength. A comprehensive guide for civil engineers. Whether you are a student, professional, or builder, this step-by-step guideline will help you design a strong and durable concrete mix for reinforced cement concrete, RCC, structures. Let's begin. Chapter 1. Understanding Concrete Mix Design. The civil engineering world of concrete mix design, using the guidelines from Indian Standard 10262 and Indian Standard 456. In this comprehensive tutorial, you'll learn step-by-step procedures for designing a suitable concrete mix for reinforced cement concrete, RCC, structures. Concrete mix design is the process of determining the right proportions of cement, water, fine aggregates, and coarse aggregates to achieve the desired strength and durability. The key steps include calculating target strength, determining the water-cement ratio, selecting water content, and proportioning the
Intro, hook and introduction. Dynamic intro. Intro with construction, concrete pouring, and reinforced structures. Welcome to Civil Engineering Edge. Today, we dive deep into concrete mix design using the guidelines from IS 10262 from Indian Standard and Indian Standard. Whether you're a student, professional, or builder, this step-by-step tutorial will help you design a strong and durable concrete mix for reinforced cement concrete RCC structures. Let's begin. Chapter 1. Understanding Concrete Mix Design. Animated. Explanation of mix design process. The civil engineering world of concrete mix design using the guidelines from IS 10260 from IS 10000, IS 400. In this comprehensive tutorial, you'll learn step-by-step procedures for designing a suitable concrete mix for reinforced cement concrete RCCs. Concrete mix design is the process of determining the right proportions of cement, water, fine aggregates, and coarse aggregates to achieve the desired strength and durability. The key steps include calculating target strength, determining the water-cement ratio, selecting water content, and proportioning the aggregates. Here, the following steps are involved for calculating concrete mix for reinforced cement concrete RCC structures. Concrete mix design M20 grade? 1. Target strength. 2. Water cement ratio. 3. Water content. 4. Calculation of cement content. 5. Aggregate proportion between CA and FA. 6. Mix calculation. Chapter 2. Data required for proportioning. Visual, tabular representation of data requirements. Before we start, let's look at the key data required for mix proportioning. Stipulation for proportioning. Grade of concrete, M20. Cement type, OPC ordinary Portland cement. Max nominal aggregate size, 20 millimeters. Exposure condition, mild is 4. Maximum. Table 3. Minimum cement, 300 kilograms. M3 is minus 456. Table 5. Workability, 100 millimeters. Slump IS for 56. CL.71. Placing method, pumping. Transportation time, 30 minutes. Standard deviation, 4.0 mm. IS 10262. Table 2. Type of coarse aggregate, crushed angular aggregate. Maximum cement content minus 450 kilograms. MA is dash for 56, CL.8.2. for .2. Fine aggregate. Zone 2. Water cement ratio, 0.50 IS for 56. Table 5. Test data of materials. 1. Specific gravity of cement, 3.16. 2. Specific gravity of fine aggregate, 2.46. 3. Specific gravity of coarse aggregate, 2.73. 4. Specific gravity of water, 1.00. 5. Admixture type, Super plasticizer. Chapter 3. Step-by-step mix design calculation. Visual, stepwise calculations with formula displayed on screen. 1. Target strength calculation. Formula: FCK equals FCK plus 1.65 times SS standard deviation. IS 10262-019, table, to P.03, S 4.0, a May, X factor based on grade of concrete as per table 1, X 5.5, a May, given, FCK equals 20 nm, S equals 4.0 un per square millimeter. FCK equals 20 plus 1.65 times for equals 26.6 un per square millimeter. 2. Water-cement ratio determination. Exposure, mild. From IS 456, Table 5, WRC ratio equals 0.55. It can be reduced since we use admixture. Reduction due to admixture, 0.50. 3. Water content calculation. IS 10262, Table 4, no -5. 20 millimeters aggregate, 186 kilograms for 50 millimeters slump. 100 millimeters adjusting for 100 millimeters slump. Plus 6% gives 197 kilograms. Reduction due to super plasticizer, minus 20% gives 157.6 kilograms. 4. Cement content calculation. Cement equals water, WRC ratio equals 157.6, 0.50 equals 315 kilograms per cubic meter. Equals 157.60 per meter 300 kilograms, MA. This satisfies the minimum requirement of 300 kilograms per cubic meter. 5. Aggregate proportioning CA, FA ratio. IS 10262, Table 5, zone to sand equals 0.62. For every 0.05 increase, reduce 0.01. WSC a 0.55, 0.05, 0.55 equals 0.05. Adjusted for WSC ratio 0.50, 0.61. For pumpable concrete, CA can be reduced up to, so volume of coarse aggregate equals 0.61, 10% of 0.61. Volume of coarse aggregate, 0.5 for 9. 6. Final mix proportions. A volume of concrete equals 1 MA. B. Volume of cement. Mass SP. Gravity X. 1/1000th equals 315 per 3.16 x equals 0.099 MA. Volume of water. Mass per second 10/1000th equals 157.6 equals 0.158 meters 3. The volume of admixture, mass, SP. Gravity, 10/1000th. Mass 1.1% of cement, x 315, 1.12 x 1000 equals 0.0031 MA. E. Volume of all in aggregate 0.1, B plus C plus D. Equals 1-0.099 plus 0.158 plus 0 equals 0.740 F. Mass of coarse aggregate. Volume of all in aggregate x volume of SP. Gravity of CA by 1000 equals 0.74 x 0.5 for 9 x 2.7 3 x 1000 1110 kilograms. G. Mass of fine aggregate. Vol of all in aggregate x vol of FAX SP. Gravity of FAX 1000 0.7 for x 0.451 x 2.46 x 1,821 kilograms. Summary: cement equals 315 kilograms per cubic meter. Water equals 157.6 kilograms per cubic meter. Fine aggregate equals 821 kilograms, M. Coarse aggregate equals 1,110 kilograms, M. Admixture equals 3.465 kilograms per visual. Summary table of final mix proportions. Chapter 4, Practical Implementation. Visual. On-site footage of concrete batching, mixing, and quality checks. Now that we've designed the mix, it's crucial to implement proper batching and quality control on-site. Always ensure accurate measurements and perform slump tests to verify workability. Chapter 5, Conclusion and Benefits. Comparative. Visuals of well-designed versus poorly designed concrete structures. Using a properly designed concrete mix has several advantages, including enhanced strength and durability, ensures that structures last longer and withstand environmental factors. Cost-effectiveness. Optimized mix proportions reduce material wastage and enhance efficiency. Improved workability ensures ease of handling, placement, and compaction, reducing construction delays. Crack resistance. Well-calculated water-cement ratios prevent shrinkage cracks and structural failures. Environmental benefits. Reduced cement usage lowers carbon footprint, making construction more sustainable. By following IS 10262 and IS 456 guidelines, we achieve an optimized concrete mix design that meets industry standards while ensuring reliability and strength. Outrow. Call to action. Civil engineering. Edge, like, and subscribe and that's how you master concrete mix design for optimum strength. If you found this video useful, give it a thumbs up, subscribe to Civil Engineering Edge, and hit the bell icon for more valuable content. Comment below if you have any questions. See you in the next video. End scene. Fade out with background music.
Welcome to Civil Engineering Edge. Today, we dive deep into concrete mix design using Indian Standard 10262 and Indian Standard 456 guidelines. Mastering concrete mix design, M20 grade, for maximum strength. A comprehensive guide for civil engineers. Whether you are a student, professional, or builder, this step-by-step guideline will help you design a strong and durable concrete mix for reinforced cement concrete, RCC structures. Let's begin. Chapter 1, Understanding Concrete Mix Design. The civil engineering world of concrete mix design, using the guidelines from Indian Standard 10262 and Indian Standard 456. In this comprehensive tutorial, you'll learn step-by-step procedures for designing a suitable concrete mix for reinforced cement concrete, RCC structures. Concrete mix design is the process of determining the right proportions of cement, water, fine aggregates, and coarse aggregates to achieve the desired strength and durability. The key steps include calculating target strength, determining the water-cement ratio, selecting water content, and proportioning the aggregates. Concrete mix design fundamentals. Understanding the role of cement, aggregates, and water in concrete mixtures. The importance of the water-to-cement ratio in determining concrete strength and workability. Introduction to common concrete mix design parameters. Slump, compressive strength, and air content. Here, the following steps are involved for calculating concrete mix for reinforced cement concrete, RCC structures. Concrete mix design M20 grade. 1. Target strength. 2. Water cement ratio. 3. Water content. 4. Calculation of cement content. 5. Aggregate proportion between coarse aggregate and fine aggregate. 6. Mix calculation. Chapter 2. Data required for proportioning. Before we start, let's look at the key data required for mix proportioning. Stipulation for proportioning. Grade of concrete, M20. Cement type, OPC, ordinary Portland cement. Max nominal aggregate size, 20 millimeter. Exposure condition mild, IS 456, Table 3. Minimum cement 300 kilogram per meter cube, Indian Standard 456, Table 5. Workability, 100 millimeter slump, IS 456, close point 71. Placing method, pumping. Transportation time, 30 minutes. Standard deviation, 4.0 Newton per square millimeter. Indian Standard 10262, Table 2. Type of coarse aggregate, crushed angular aggregate. Maximum cement content, 450 kilogram per meter cube. Indian Standard 456. Close point 8.2.4.2. Fine aggregate zone 2. Water cement ratio, 0.50. Indian Standard 456, Table 5. Test data of materials. 1. Specific gravity of cement, 3.16. 2. Specific gravity of fine aggregate, 2.46. 3. Specific gravity of coarse aggregate, 2.73. 4. Specific gravity of water, 1.00. 5. Admixture type, superplasticizer. Chapter 3. Step-by-step mixed design calculation. 1. Target strength calculation. Formula. FCK equals FCK plus 1.65 into S. S standard deviation. Indian Standard 10262, 2019, Table 2, page no. 3. S 4.0 Newton per square millimeter. X factor based on grade of concrete as per Table 1. X 5.5 Newton per square millimeter. Given FCK equals 20 Newton per square millimeter. S equals 4.0 Newton per square millimeter. FCK equals 20 plus 1.65 into 4 equals 26.6 Newton per square millimeter. 2. That water cement ratio determination. Exposure mild. From Indian Standard 456, Table 5. Water cement ratio equals 0.55. It can be reduced since we use admixture. Reduction due to admixture, 0.50. 3. Water content calculation. From Indian Standard 10262, Table 4, page no. 5. 20 millimeter aggregate, 186 kilogram for 50 millimeter slump. 100 millimeter slump. For every 25 millimeter add 3%. Indian Standard 10262, Klaus point 5.3. Adjusting for 100 millimeter slump, plus 6%, 197 kilogram. Reduction due to superplasticizer, minus 20%, 157.6 kilogram. 4. Cement content calculation. Cement equals water divided by water cement ratio equals 157.6 divided by 0.50 is equal to 315 kilogram per cubic meter. Equals 157.60 divided by 0.50 is equal to 315 kilogram per meter cube is greater than 300 kilogram per cubic meter. This satisfies a minimum requirement of 300 kilogram per cubic meter. 5. Aggregate proportioning, coarse aggregate, fine aggregate ratio. Indian Standard 10262, Table 5. Zone 2 sand equals 0.62. For every 0.05, increase reduce 0.01. Water cement ratio 0.55. 0.05 to 0.55 equals 0.05. Adjusted for water cement ratio 0.50. 0.61. For pumpable concrete coarse aggregate can be reduced up to 10%. Indian Standard 10262, Klaus point 5.5.2. So, volume of coarse aggregate equals 0.61, 10% of 0.61. Volume of coarse aggregate, 0.549. 6 final mixed proportions. A. Volume of concrete equals 1 cubic meter. B. Volume of cement, mass divided specific gravity, into 1 divided by 1,000. Equals 315 divided by 3.16 into 1,000. Equals 0.099 cubic meter. Volume of water, mass divided by specific gravity, into 1 divided by 1,000. Equals 157.60 divided by 1.0 into 1,000. Equals 0.158 cubic meter. D. Volume of admixture, mass divided by specific gravity, into 1 divided by 1,000. Mass, 1.1% of cement. 1.1 divided by 100 into 315 divided by 1.12 into 1,000. Equals 0.0031 cubic meter. E. Volume of all in aggregate. 1 B plus C plus D equals 1. 0.099 plus 0.158 plus 0.0031 equals 0.740. F. Mass of coarse aggregate. Volume of all in aggregate into volume of specific gravity of coarse aggregate into 1,000 equals 0.74 into 0.549 into 2.73 into 1,000 is equal to 1,110 kilogram. G. Mass of fine aggregate. Volume of all in aggregate into volume of fine aggregate into specific gravity of fine aggregate into 1,000. 0.74 into 0.451 into 2.46 into 1,000 is equal to 821 kilogram. Summary. Cement equals 315 kilogram per cubic meter. Water equals 157.6 kilogram per cubic meter. Fine aggregate equals 821 kilogram per cubic meter. Coarse aggregate equals 1,110 kilogram per cubic meter. Admixture equals 3.465 kilogram per cubic meter, 1.1% of cement. Water-cement ratio equals 0.50. Cement Fa. C. Water. 315 821 11 10 157.60. 12.61 3.53 0.50. Chapter 4. Practical implementation. Now that we've designed the mix, it's crucial to implement proper batching and quality control on-site. Always ensure accurate measurements and perform slump tests to verify workability. Chapter 5. Conclusion and benefits. Using a properly designed concrete mix has several advantages, including enhanced strength and durability, ensures that structures last longer and withstand environmental factors, cost effectiveness, optimized mix proportions reduce material wastage and enhance efficiency, improved workability, ensures ease of handling, placement, and compaction, reducing construction delays, crack resistance. Well-calculated water-cement ratios prevent shrinkage cracks and structural failures. Environmental benefits. Reduced cement usage lowers carbon footprint, making construction more sustainable. By following Indian Standard 10262 and Indian Standard 456 guidelines, we achieve an optimized concrete mix design that meets industry standards while ensuring reliability and strength. And that's how you master concrete mix design for optimum strength. If you found this video useful, give it a thumbs up, subscribe to Civil Engineering Edge, and hit the bell icon for more valuable content. Comment below if you have any questions. See you in the next video.